Hi guys! So today we're going to be talking about the constant rate of change. So let's first talk about the definition of that. So the constant rate of change is the amount between one x value to another stays the same, and so does the amounts between the y values. Alright, so first we're going to go over the constant rate of change in a table first, because it'll lead us right into finding the constant rate of change on a graph. So on this table we have the x and the y values. The x values are 2, 4, 6, 8. So we can see that going from 2 to 4 is plus 2, 4 to 6 is plus 2, and 6 to 8 is plus 2. So the constant rate of change in the x is 2. And then for the y value, it goes 6 to 12, 12 to 18, 18 to 24. It's all plus 6, plus 6, plus 6. So the constant rate of change of y is 6. So change of y, 6, over change of x, 2. And we can simplify this to 3. So the constant rate of change is 3 in that graph. Alright, but now we're going to be looking at it on a graph. Remember that on each graph we need to have a title, we need to label what our y-axis is and what our x-axis is. So in this graph, this graph represents the distance traveled, in a certain amount of time while going on a road trip. Looking at this graph, we can see that x-axis represents time in hours, and the y-axis represents distance in miles. So the rate of change would look something like this. The change in miles over the change in hours, because this would be the change in y over the change in x, like we talked about in our table. This also could be known as rise over run. So in order to find the constant rate of change, we're going to need to use another equation, which is y1 minus y2 over x1 minus x2. And this equation will equal the constant rate of change. So what do we need to do to determine the constant rate of change of this line? We need to find 2 points on the line. As you can see, this graph has given us a few points on the line. We need to choose any 2. Let's do 2, 100, and 6, 300. This will be our x1 and y1, and this will be our x2 and y2. So we're just going to copy what our equation is. So y1, which is a 300, minus our y2, which is 100, over our x1, which is 6, minus our x2, which is 2. So 300 minus 100 is 200, and 6 minus 2 is 4. Now we need to look and see if we can simplify this. We can. 4 goes into 200 50 times. So our constant rate of change is 50. So since we know that for the constant rate of change, any point on this graph, we should get the same number for the constant rate of change, which is 50. So let's put this to the test. Let's compare two different points. So let's stick with our 2 and 100. And let's also do 10 and 500. So again, this will be our x1, this will be our y1, this will be our x2, this will be our y2. All right, let's set it up using that equation. So 500 minus 100 over 10 minus 2, which 500 minus 100 is 400, and 10 minus 2 is 8. 8 goes into 450 times. So it does work. So our constant rate of change for this line is 50. So this also means that every 1 hour traveled on this road trip, they travel 50 miles. So just to recap, you pick any 2 points on a graph, rise over run. It'll be the change in miles, or the change in the y's over the change in the x's, and this would be your equation. y1 minus y2 over x1 minus x2, and then you will get the constant rate of change.